Pretty much this entire unit we've talked about angles, angle relationships, different types of angles, linear angles, vertical angles, all the angles you get with parallel lines, things like that. Well, in this lesson, we're going to talk about angles within triangles. Okay? There's this important theorem called the angle sum theorem. And that says that the angles of a triangle will always add to 180 degrees. No matter if it's an acute triangle, an obtuse triangle, or a right triangle. Doesn't matter how big the sides are or how small the sides are. All the angles will always add to 180 degrees. And we don't need laptops. Okay. So, in this triangle, with that theorem, if we add whatever the measure of angle A is, plus whatever the measure angle B is, plus whatever the measure of angle C is, it will give us 180 degrees every single time. That's what that theorem says. So to practice this, before we practice it, why is this true? Why do all the angles of a triangle always add to 180 degrees? Someone discovered this, right? And this is their very informal argument as to why this is true. Okay? We'll get to a more formal one later, but this is why all the angles of a triangle always add to 180 degrees. Okay, we want to show that using this diagram. So using the angle addition postulate, we know that angle 4 plus angle 3 plus angle 5 equals this angle right here. Okay? We add up all three of those angles together, we get angle EAD. Well, what do we know about angle EAD? What do we know about angle EAD? It's a what type of angle? It's a straight angle. And what do straight angles always equal? 180. So because that's a straight angle, we can replace EAD in that equation. We can plug in 180 degrees for EAD to get a new equation. Whatever angle 4 is, plus whatever the measure of angle 3 is, plus whatever the measure of angle 5 is, will give us 180 degrees. Just like we did with linear pair angles. And because those three angles are adding to a straight angle, those three angles are going to add to 180 degrees. Okay. Well, if we also look, EAD is parallel to CB. There's arrows on it, so remember arrows mean those lines are parallel. And they're never going to intersect. So because they are parallel lines, we know angle 1 is congruent to angle 4, and angle 2 is congruent to angle 5. The reason is, and it might help if we extend the bottom here, I'm going to extend CB. Okay. And each side's acting as a transversal. We kind of extend things here. What kind of angles are angle 1 and angle 4? Yeah, they're alternate interior. If I make this a transversal, what type of angles are 2 and 5? They're also what? Alternate interior. And what do we know about alternate interior angles? They're congruent. They're the same. So we can say that 1 and 4 are the same because they're alternate interior angles. We can also say 2 and 5 are the same because they are alternate interior angles. And we know alternate interior angles are congruent. Well, because 1 and 4 are the same, they're congruent, and 2 and 5 are the same, we can replace them in this equation. I believe it's a 3 on your paper. We can replace this in this equation, okay? And there's a blank down here. To get a new equation. Because 1 is the same as angle 4, we can take 1 and rewrite it where angle 4 is. Plus, nothing was the same as angle 3, that's going to stay angle 3. 2 was the same as 5. So we can take 1 write it where the 2 is. They're the same. So we're allowed to do that. Right? And we get that they are equal to 180 degrees. And that's why it works. So essentially, breaking it down a little bit more, 4, 3, and 5 all add up to a straight angle. The 4, 3, and 5 add to 180 degrees. Well, because 1 is the same as 4, they're the same measure. 2 is the same measure as 5. They're also going to add to 180 degrees with angle 3. Because if 4, 3, and 5 add to 180, then 1, 2, and 3 also have to add to 180. Because 1 and 2 are the same as 5. Okay. That's why that works every time. And we'll do a even more formal argument later in the year. That's just the basics. You're not going to be asked this on a test. This is just explaining to you why this works. Okay? You're going to be asked more things like this. You're going to be asked how to apply it on a test. Okay? So, using the diagram below, we want to find the measure or the value of x. And I notice x is an angle inside of a triangle. What do we know about all the angles of a triangle? What do they add up to? 180. So we know that 88 plus 24 plus x is going to equal 180 degrees. And then just solve for x. What do we get when we do 88 plus 24? Move the 112 over. What's 180 minus 112? 60. So x is 68. The angle is 68 degrees. Okay. You also could have, as a shortcut, because this was just a variable, you're just trying to find that single angle, there was no expression in there, you could have just done 180 minus 88 minus 24 and still gotten the right answer. Both ways are right. One way's a little bit quicker than the other. Just put in your calculator rather than having to set up an equation. Okay. The reason why I showed you the equation set up first is because for b, we can't use this green method up here. Okay? Because there's an x in all the angles. Okay? And things are being added and subtracted to x. We have to set up our equation. So you want to find the value of x. Well, what do you think we have to do to solve it? What do you know about all the angles of a triangle? 180. So you literally add all of them up. X plus x minus 31 plus x plus 43. Add all the angles together and set it equal to 180 degrees. And then you solve. Combine your like terms. When I do x plus x plus x, what do we get? X, good. And then negative 31 plus 43, what do we get? Move the 12 over. Divide by 3. Oh, what do we get when we subtract 12? Sorry. 168. Then divide by 3. And x ends up equaling what? What is it? 56. Very good. So x is 56 degrees. Questions over that? So knowing that all the angles of a triangle add to 180 helps you set up that problem. Questions over that? Let's try another example. Using the diagram to go below, we're going to find the value of missing angles. I love these type of problems. I like to think of them as little puzzles. Okay? We want to find, in the first one, we want to find angle 2, angle 1, and angle 3. Which one can we find first? Angle 1. How can we find angle 1? Yeah. I notice we have a triangle right here. We know all the angles of a triangle add to 180. So we can do 180 minus 43 minus 74. And what do we get when we do 180 minus 43 minus 74? 62. So now I know angle 1 is 62 degrees. I'm also going to fill it in my diagram because that's going to help me find the other ones. It gives me a good visual about what the other ones are. Not filling it in makes it harder, more difficult. Fill in your diagram. What other angle can we find? Kel?
I was going to say, I thought it was 60.
Is it 63?
Yeah.
Okay. I heard 62. How can we find angle 2? What does angle 2 equal? Haley? Good, how'd you know it's 63 degrees? Good. It's vertical to angle 1. Angle 1 and angle 2 are vertical angles. That means they are the same. So if 1's 63, 2 is going to be 63. How can we find the measure of angle 3? Our last angle. What's angle 3 going to equal? Kevin? Good. How'd you get 38? Good. Yeah, we have another triangle here. We have a separate triangle. And Kevin knew all the angles of a triangle add to 180. So if I subtract the two other angles, you do 180 minus 63 minus 79, you get 38. If we take a look at B, similar kind of concept. We need to find angle 1, angle 2, angle 3, and angle X. Which one can we or do you want to find first? There's two that we can find right away. Good. How'd you find angle 3?
180 minus 72 minus 19.
Very good. We have a triangle here. Subtract these from 180 to get that third angle of your triangle. So 180 minus 91 minus 72. What did that give you? 17. So angle 3 is 17 degrees. What other angle can we find?
2 would be 91.
Yeah. 2 is 91 because they're what? What do we call those ones? Starts with a V.
Vertical.
Vertical, very good. 2 is 91 because it's vertical to 91 degree angle. So they're the same. I like what your thought process there, Reese, with like corresponding angles and thinking about parallel lines, because if you notice here, we have arrows on these lines. What do arrows mean again? Not perpendicular. Tick marks means they're congruent. What is it? Parallel. Arrows on lines or arrows on sides mean they are parallel to each other. So these two lines are parallel, and if it helps, I'm going to kind of darken them. These two lines are parallel to each other because they have arrows. This middle line right here is acting as a transversal. So what kind of angles are 1 and 72? Alternate interiors. These are what? The same. So if this angle is 72, what's angle 1 going to be? 72. With that knowledge, is there another angle we can find? Yeah. What's the measure of x? 17. Very good. Same exact thought process. If I extend this line here, angle 3 and x are also alternate interior angles. So x has to be 17. You also could have just done 180 minus 72 minus 91. I got 17. Okay. Questions over that? On the back, the isosceles triangle theorem. We're not going to go over the informal explanation of why this works. We'll talk about that later down the road. There's more things we need to learn before we can do that. But essentially, what the isosceles triangle theorem says is that if two sides of a triangle, so if you have an isosceles triangle, so if AB is congruent to BC, if those two sides are the same, the angles across those sides are also going to be the same. So angle C, if I start on that side and go across, angle C is directly across from AB. So that angle is going to be congruent to A because it's directly across from that other congruent side. So if these two sides are the same, the angles across those sides are also going to be the same. That's what the isosceles triangle theorem says. The converse just means it's backwards. So the converse of the isosceles triangle theorem says if the angles are the same, then the sides will be the same. So that means if A is congruent to C, you go directly across, that means BC is going to be congruent to AB. So it's just the same thing but in reverse. So the two sides are the same, the angles will be the same, the angles are the same, and the two sides will be the same. Vice versa. It's like what I like to think of like converse. Okay. Questions over that. So we take a look at these examples. If we look at A, we want to find the value of x. I notice x are angles inside of a triangle. What do we know about all the angles of a triangle? Equal 180. What's the problem here? Why can't we just add all this up and set equal 180 degrees? Yeah, very good. We only have two angles. We don't know what that top angle is. We have no idea what it is. We can't assume what it is. We have to be told. So we can't just do 2x minus 27 plus x plus 53 plus the top angle because we don't know what it is. But what do you notice about these two sides? They're equal. Well, what did we just learn? What do we know about the two angles across from those sides? They're what? Yeah, they're also equal. We have an isosceles triangle. If those two sides are the same, the angles directly across from those two sides are also going to be the same. So then, very good. You can just set them equal to each other. So when you have an isosceles triangle, set those two congruent angles equal to each other. I don't remember if it's a minus or. So you do 2x minus 27 equals x plus 15. And then solve. Move the x over. Add 27. So x is equal to 53 plus 27. So x equals 2. Questions over that? So sometimes with isosceles triangles, you just have to recognize that those angles are congruent and set them equal. What about B? This time around, what were we given? Were we given sides or angles? Sides. Do sides of a triangle add up to 180 degrees? No. Only angles, not the sides. Sides can be different. Okay? The perimeter of all triangles is not 180, just the angles. So to figure out how to get x, what was my only information given? What two things are the same? The angles, right? They mark that S and T are the same because they have the same arcs. Well, if these two angles, if S and T are the same, what do we know about the sides across from those angles? They're the same. So I start at T, the side across from T is here. Start at S, go across. Those two sides are the same. So they're the same, what can we do? Set them equal. And then solve for x. Little hint, with sides, that's about all you can do. So if all else fails, if you're given sides and you don't really know what to do, just set them equal. That's about all you can do with sides. Angles, you can do a ton of things. Sides, segments, set them equal and solve. That's about all you can do. Then move the 6 over. And x is equal to what? Questions over that? So with this one, in the diagram below, find the value of x. Well, I know this angle in the bottom left corner is 2x plus 3. What's the measure of this top angle? 90. Is that box? What's the measure of this angle? You don't know?
Second one is 2x plus 3.
Yeah, very good. Why? It's the same. Why is it the same? Yeah, we have an isosceles triangle. So when those two sides are the same, again, the angles across from those sides are the same. So if this is 2x plus 3, what's this angle going to be? 2x plus 3. Now how can we figure out what x is? Do that. Let's see what happens. I like your thought process. Because we are the same, what's going to happen when we set them equal? Yeah, everything goes away, right? So what do you think we need to do? You can set it on 90, or you can add everything up and set it equal to 180. Both are correct. And I'll show you why both are correct. I'm going to do the 180 method. So this angle plus this angle plus this angle equals 180. All the angles of a triangle add to 180 degrees. You also could have said 2x plus 3 plus 2x plus 3 equals 90. Because if this top angle equals 90, then the other two angles added together also have to equal 90. But just for habit's sake, I'm going to add all three of them up and set it equal to 180 degrees. So combine my like terms, I get 4x plus 3 plus 3 plus 90 is what?
96.
96, good. Move the 96 over.
84.
Then we get 84. Divide by 4. X ends up equaling what?
21.
Yep. 90. You don't have to write it. But just for habit's sake, because sometimes you'll have it. Just when you see a triangle, it doesn't always work. It only works with right angles. So, just for habit, I like to do 180. But if you recognize that that's a right triangle, you can just add it to 90. It is a lot less work. Questions over that? Okay, two more. They're kind of quick, and they're like the little puzzle ones again. Now that we understand theorems involving triangles, the angle sum theorem and the isosceles triangle theorem, we can look at two corollaries that are a direct result of the angle sum theorem and isosceles triangle theorem. A corollary is just a statement that follows with little or no proof from another theorem. Okay? And we'll see why this works. So it's pretty much you already proved a theorem, and then you get another idea from that proof. You don't really have to argue it as much. It's kind of like a postulate in a way. So the first corollary is a triangle is equilateral if and only if it's equiangular. We talked about this a little bit, and here's why we talked about that earlier. This is why it works. So I draw my equilateral triangle. Okay? All three angles are the same. Using that isosceles triangle theorem, we said if two angles are the same, the sides across from those angles are also the same. Okay? But aren't these two angles that I'm highlighting in orange also the same? So won't those two sides also be the same? Yeah. So because the bottom orange angle side has one tick mark, then the side across from the top orange angle is also going to have one tick mark. Meaning because all the angles are the same, all the sides are also going to be the same. Using that isosceles triangle. Okay. Questions? The other corollary we got, that uses the angle sum theorem. Each angle of an equilateral triangle has a measure of 60 degrees. Because all the angles have to add to what? 180, right? Well, the only number that you can triple to get 180 is 60 degrees. So you have to be able to do 60 plus 60 plus 60 equals 180. Okay. The only number you can triple and get 180 degrees, because all the angles have to be the same. Have to be the same angle measure. Okay. Questions over that? So to use those in a problem, here, what type of triangle were we given? Equilateral in A. We were given an equilateral triangle. What do we know about equilateral triangles? All the sides and angles are the same, so all these angles are the same. Knowing that, what do we know about all the angles? They're all 60. So if they're all 60, how can we set up this problem to solve? 6x equals 60. Yeah, all the angles equal 60. So we take what angle F is, which is 6x, and set it equal to 60 degrees. And solve. Just divide by 6, and x is equal to what? You also could have done, since all the angles are the same, you could have done 6x here, 6x there, 6x there, and 6x plus 6x plus 6x equals 180, and still gotten it. This is more work. This is less work. Than equals. And this last one, we need to find x and y. How can we find them? Ryan?
Since it's an equilateral triangle.
This guy right here. Equilateral.
All the angles are 60 degrees.
Good. So all these are 60.
Subtract 60 from the 90 degree angle, which is 30.
Good.
And then
So right there. This is 90, as Ryan said. This is 90. So this is 60. So to get this little angle right here, you just do 90 minus 60, and that will give you that angle is 30. Because these both have to add to 90. Then what do we do?
And since it's an isosceles triangle, it's x is 30.
Good.
And
Stop. Pump the brakes. You're doing a great job. So that's an isosceles triangle. So we know the base angles, the sides across from the equal sides are also the same. So we found x. X is 30. This angle is 30. That means this has to be 30. Okay. How can we find y?
Subtract 60 or 180 minus 60 or 180 minus 30.
Yeah, just subtract the other two angles because then we have a triangle. So to figure out the third angle, just subtract the other two from 180, and what do we get? 120. So y equals 120. Questions over that?